Welcome to the Maintainable Software Podcast, where we explore the art of improving existing software with seasoned practitioners who have helped organizations overcome the problems often associated with technical debt and legacy code. I'm your host, Robby Russell. On this episode, Marianne Bellotti, author of the books Hiring Engineers and Kill It With Fire, Building Safety-Critical Systems. Marianne is currently an engineering manager at Rebellion Defense and joins us from Washington, D.C. in the U.S. Marianne Bellotti, we're so glad to have you join us on Maintainable. Welcome.
Hi, thanks for having me.
So as you reflect on your experience in the industry, what do you believe are a few common characteristics of, dare I say, well-maintained software?
I mean, for me, the ultimate line is, can you make changes to it? And how easily can you make changes to it? A lot of the software that I deal with in legacy modernization, we get into this conversation about like, well, where does the line start for like a legacy code, right? Like, how old does it have to be? And I've always felt that was a poor way of judging software products, right? It doesn't matter how old it is. It matters of like, can you maintain it? And the first thing that we find out when people can't maintain software is like, they don't really know what it does, and they're really afraid to make any changes to whatsoever, to the point of there might be somebody who's like 50, 60, 70, sometimes 80 years old, like still creaking around in the workplace because they're the person who was around when the thing was built in the first place, and they're the only one that people feel confident they know what the impacts of changes are. So that's always the first question for me is, can you make changes to this software confidently?
You mentioned like that scenario where there's people that have been around for a long time, and we've had clients in those scenarios as well, where they have someone working at a company for 30, 40 years, and they know how everything works, but that person's supposed to retire maybe already, but they haven't for whatever reason, and then like there's this challenge for teams to like, well, if they leave, what happens then? Like it's all going to come falling down. Have you seen some good patterns for how teams can like offset that well for someone that's clearly would like to leave, but they're worried that everything's going to fall down once they walk out the door? They might have a lot of guilt or whatever the reason, just they have that institutional knowledge, but it's hard for them to like sometimes relinquish that in some way as well.
I mean, the first step to getting a better scenario for everyone is developing a plan around testing, right? So in some cases, that means having a designated testing environment where the software can break. The computer system can break and there are no consequences because it's not a production environment. And then going through inputs where we know what the outputs should be and figuring out how we're automating that, right? And getting that like happy path worth of testing and slowly building out our test cases, because that's really what gives people confidence when they want to make changes on a system, is to be able to run a set of unit tests, maybe a set of integration tests, and see those little check marks appear on the screen to know that the defined outputs are not affected by changes. So that's usually where I start, is like, okay, what's really normal is that organizations will have a lot of that work done, but it'll be manual. They'll be in the land of manual QA testing. So they'll have a defined set of test cases of like, this is what should happen in these conditions when we run these commands. And so it's really great to start from that point because the thought has been done. Now it's just about the tooling. And then from that point on, it's just allowing people to sort of naturally start to build confidence that the system can be iterated on. I mean, like, I never want to encourage institutional memory to be lost, but I always feel like, is the person who's kind of hanging around and delaying their retirement, like, what do they want, right? Do they, like, some people, certainly my parents were like, we're done. We're going to travel now. Like, that's it. We're over. But I also know people that like, this is a really big part of like their identity and how they feel valuable and the contribution that they make. So it's not really necessarily about like removing like older people from the workforce, but it is about like making sure that everybody can have the arrangement that they want in life, right? Nobody should be chained to the desk because like, oh my God, if you leave, this system that is essentially holding the entire banking infrastructure goes down, and then there will be disaster, right?
It's true. So I work in the consulting world, and we got pulled into a project a couple of years ago where there was someone that had been at the company for 30 something years, potentially even almost 40, and had written a bunch of stuff in a more modern framework, but had really struggled to bring on other people onto the team to help provide support to the platform, because they just had all this wealth of knowledge about how the organization operates, because it was like an internal related tool. Like they knew that they wanted to leave and go retire, but felt this weird, lack of a better word, guilt or responsibility that like when they walk away, like things would come crumbling down. And so that they're, I think, protecting their own legacy in some ways and their impact on the company. But it was very difficult for other people to get onboarded into that environment. I didn't know how to best go into that scenario and help coach them through that challenge, because it wasn't that I felt like they didn't want to leave. It was just more of it was guilt, and maybe also a little bit of, if I had only had more time to make this simpler for other people, like I wish I had had more time. So there's like a little bit of like carrying it on, like feeling like it's their burden because they wish that they had done it differently or better documented or better explained things so that other people could get onboarded to that particular piece of software.
It's also for some people, and if actually I say for a lot of people, 30 years of your life has been invested in maintaining this piece of software. And if it falls apart as soon as you leave, there's this feeling of like, well, what did I do for 30 years of my life, right? And so there are a lot of complex emotions that like kind of put people in these positions. But the fact of the matter is that like nobody being confident that the software can run without one person is a bad scenario, no matter who the person is, no matter like what the context around it is. We never want to be put in that situation where there's this one person, and if they get hit by a bus or struck by lightning or just want to go move to Fiji for the rest of their life, right, that would be an absolute disaster. So when we find ourselves in those sort of situations, we want to sort of treat it as like a confidence issue within the organization and figure out how do we build confidence and faith and trust in the system and our ability to change it.
It was interesting talking with other people that had been more recently recruited to the team, and their perception was that person will just not let go. And there was like this, and maybe there might be some people listening, potentially even people that were part of that company listening to the podcast. For those that are like the newcomers and they're finding that they're hitting that friction point of being like, I don't feel like they're releasing it. They don't believe that I can take on this project. And so that's like an interesting dynamic. Do you have any advice on what you would offer those people on like how to maybe approach that person that's seemingly not ready to let go?
Yeah, I would say that a lot of the stuff, and by stuff I mean process and tooling, that we develop in order to build high quality software at scale are also really useful in negotiating some of these interpersonal organizational issues, right? So if I have a tech lead on my team that doesn't trust anybody else to contribute to a particular piece of software, my first instinct is to go look at what our CI/CD process looks like, right? Because like if there's something that's not covered in the pipeline, if there's a check that we should be running, if there's something that go wrong that's not reflected in our CI/CD pipeline, then perhaps we should change our CI/CD pipeline so that it is reflected, right? And so I like to take these kind of situations and step away from individual people's feelings, like a half step back and kind of go, well, we should trust these systems that we put in place to make sure that we are deploying software correctly and that all of the I's are dotted and all of the T's are crossed. And if we don't trust these things, then we should fix these things so that we do trust them. And I feel once you take away that emphasis on that one particular person and their feelings, and you just make it, no, in general, like we want to be able to trust the process, then that kind of helps ease some of the tension there. But I will say that you hit on a really good point. Like, I think it's very obvious and somewhat unhelpful to tell people, well, don't end up in a situation where you have one person that's supporting the entire world. Like, I think most people know that would be a bad scenario, but like, what is the pathway to that scenario? And I think the first sign is often how long does it take you to onboard new engineers. So when I'm talking with people about well, does this system need to be changed? Do we have a problem? That's often the first question I ask them when we're trying to just assess whether they have a problem. It's like, well, okay, so how long does it take you to onboard a new engineer? If we hired an engineer today, when would you be expecting them to make like contributions to production? And that number, there's no hard and fast number on that, because like you'll have some organizations that will say like, well, day one. And then some organizations will say week one. And then some organizations are a little bit more conservative. And sometimes that's not about the quality of the technology. Sometimes that's about the regulatory landscape or actually the norms of what they're working on. So I was a couple weeks ago, I was in Mountain View attending a Erlang conference, and we were talking about secure validated kernels. And like something like kernel development has a completely different release cycle than a web application. And so when you're in the world of like kernel and OS development, when you are releasing things into production and how long it takes you as a new engineer to actually like put code in a production and release, it might actually be quite longer than it is in web development. And that could be fine. That is not necessarily a signal that something is slipping. So it does vary by industry, and it's just basically, what do you think is realistic and what length of time, what length of delay gets you to start to worry?
That's a good point there. I hadn't thought about so much on the industry specific aspects to the answering that question. Because when we speak as prospective clients, I'm always curious about things like how long does it take you to onboard new people? You know, how long does it take you to push a bug fix out? Like, what are the steps that you need to go through? Like, how quickly can someone on your team push a bug fix and get it out to the people that it's impacting? Is that minutes, weeks? You know, somewhere in between, and definitely helps highlight a lot of potential areas or inefficiencies or lack, or as you pointed out, maybe areas where there's a lack of confidence because, well, we always got to run it through a QA process, and that would require that person being available or that team being available, and that might take a few days for them to get to it because they're working on other things.
It's interesting to me the extent to which the most loud and most common voices in software are web development voices, distributed web-based systems. And like, that's where I came from too. So I'm not knocking on it. I love it, but that's not the only form of software engineering that exists in the world. And like, some people do have a very different context, particularly like the regulatory environment on some of these systems is quite oppressive. And like, sometimes there's just nothing you can do about that, right? So we're at work right now, we're going through a process that the government has called authorization to operate. And it's a very arduous, long certification process. And technically, we had to go through it every single time we change any of the code in our software. So the government is aware that this is a long, arduous process and that does not reflect modern software development. So there have been some adjustments to it. But if you think about that, if every time you make a change to the code base, you have to re-go through the certification process, then yeah, you're not going to get people pushing code to production within their first week. That's not realistic.
No, it's not. Now, you know, you're talking about that, and then I often see how, as you mentioned, like web developers tend to be probably the most vocal on the web, maybe because that's where they're doing most of the work or what have you.
They build it, and then they get to monopolize the conversation on it, right?
Hi there! We hope you're enjoying this week's episode of Maintainable. While you've been listening, has anyone crossed your mind who might be looking for help with their Ruby on Rails application? Planet Argon, the producer of Maintainable Podcast, would love to meet them. In fact, we've got a pretty sweet referral bonus program set up. If you send someone our way and they sign up for Planet Argon services, we'll give them a $1,000 discount. And your reward? We'll send you $1,000 just for connecting us to the right person. Sounds like a win-win for everyone. Head on over to planetargon.com/referrals for more info. That's planetargon.com/referrals. All right, let's get back to this week's episode.
So is it a safe assumption that you lean more towards team refactor versus team rewrite?
I mean, like, I always joke with people that I'm like a relapsed anthropologist. All of my formal education was in social science and anthropology. And so I do tend to look at the organization first before I look at the actual code. And an exercise that I would do all the time with new people coming on to my teams when I was actually in the government working directly on some of these really critical old systems is we'd get these brilliant software engineers, and they come in and they look at the system and they go, oh, these people are morons. Like, why did they build it this way? This is awful. Like, this is not the way we do it at all. And they would just be like pumped up on their own ego. And so I'd get them on front of a whiteboard and I'd say, okay, this system was built in like, say, 2007. You're here, you're going to rebuild it. Show us how you would do it in 2007 technology. And it's always really interesting because what ends up happening is they start building the way they build it today. And then we start pointing out to them, that doesn't exist, right? So 2007, we don't have many of the commercial cloud things I don't think you have any commercial cloud things in 2007, to be perfectly frank. Like, you don't have these things, you don't have that, you don't have I think S3 was probably about that time, but like, yeah, so you start taking all the things off the table, and gradually, as they iterate on this and they lose more and more of the stuff they have today, they end up with a system that looks exactly the same as the system that's in front of them. And it's really great, because the primary purpose of an activity like that is really about empathy, right? As soon as they realize, oh crap, actually, these are some really brilliant workarounds for the technology and the tooling that were available at the time, then they're able to sort of come into this environment and be helpful. But I do think that like technology is a product of its time and its context. I think in software engineering, we tend to get pulled into this idea of like, there's one technically correct way to do it that will be technically correct for all time. And that is not true at all. And so I like to bring in that appreciation for its context. And also, Conway's Law is a real thing, right? I have watched people develop systems that very much reflect the patterns of the organization and its communication and its structure all the time. So I think just having an appreciation for that as well is a really great reference guide to like, okay, how are we going to make this system better, right? Once we have a little bit of that lay of the land, then I feel like we can actually talk about like, so are we putting this on Kubernetes, and like having a conversation about that, right?
I really like the way you're framing that, and like I try to be very understanding of like I don't know what it was like for the original team that worked on this piece of software. So again, I work in consulting, so we end up working on projects. We're like the second or third team that might be working on a project. Never had any experience talking to the original people on it. We don't know what they were thinking, what they were doing, or how much they had worked in the similar technology or framework prior to that particular project. And then as you mentioned, it's like, yeah, it's easy to point at something and be like, I wouldn't do it like that now, but in 2007, was this actually like a really innovative way to do it at the time? And I rarely get to work on greenfield projects, very much intentionally, because that's just not what we focus on at my company. But mainly, I don't like making all those upfront decisions. I enjoy working on I like cleaning up things, improving on things, and being curious about how things were done. And it reminds me of different eras of past web development experiences that I have and stuff. So I feel like I learn a lot by seeing other people's code as well. And like, that's a really interesting way I never would have thought it to do it that way, even in 2007, maybe. What can I learn from this? But then, yeah, I think it's easy for a lot of companies, or I'm saying it's not easy, but I think it's a challenge for a lot of companies to have people come in and be like constantly maybe pointing back and be like, we need to get these things updated with the newest things. Potentially, for various reasons. I often hear like recruitment is a challenge because maybe some people think that no one's going to want to work on this older platform because they haven't gone through larger upgrades in a decade, and they haven't had the budget for it, or the people that have stuck around, and everybody got nervous of breaking things because back to the confidence thing. So what sort of advice would you offer to teams kind of navigating that, where they're maybe thinking, should we rewrite, or maybe we shouldn't? What should they be doing before they maybe make that decision?
Yeah, so I think what's hard about these kind of questions is that they're all business decisions, right? There are scenarios where option A is the right option, and there are scenarios where option B is the right option. And then there are scenarios where neither one of those things are the right option, and you're in fact asking completely the wrong question. And so one of the things I do when I take on consulting work these days is I actually have a slide deck of scenarios, and I'll be like, oh no, we have a COBOL mainframe, and like we're having trouble hiring COBOL programmers. Do we rewrite the system from scratch in Java, or insert language here? It doesn't really matter. Or do we hire a bunch of new grads and train them in COBOL? Like, what do we do? And like actually opening this up for debate and seeing if we can get people to have like a rousing debate, because both of those are viable approaches to that problem of like, we're having trouble hiring experienced programmers in the language that our system is in. You can grow them, or you can change the language the system is in to be in a space where there's a better odds of finding talent. Like I've seen both of these things work. And it's really a question of what is the organization's actual tolerance for risk? What is the reward picture for each one of these issues? Like, what is the actual cost of doing both of them? And like, where does the organization want to invest the money? Because not every organization really likes the idea of we're going to run a training program to build people who have very little experience into the workforce that we need. But an organization like IBM loves it, right? Because like IBM's bread and butter is still mainframes today. At some point, an IBM lawyer is going to call me up and be like, stop saying that. That's not true. But like a huge part of what they do is still invested in mainframes. And so from their perspective, bringing people in and training them on the languages and the technologies that are also common with mainframes makes a lot of business sense. That's probably not necessarily the case for another organization where their core business really has nothing to do with these technologies. Their systems just happen to be in these technologies. So I really like to encourage the perspective that like both of these options are good potential options. It's really about the organization figuring out where it wants to invest its time, its energy, and its money. I think that sort of takes some of the vitriol and drama out of these conversations. When people don't think like there is one right answer and like this is the silver bullet that we must apply in all of these scenarios, and they just realize that it's really about organizational priorities, it becomes easier to have these conversations without people getting very upset about their outcome.
Right. You think about these two options, and I suppose the third option is to maintain the status quo of how, just like this, we're going to keep doing what we're doing, and we'll come back to this topic one day in the future because we're not ready to make a big decision on whether or not we want to do a major refactoring or recruit a bunch of people and train them up, or start the big rewrite, because people have said that might result in chaos as well. For the people that are rewriting it, going to set things up better next time than we did the first time, or will we be in the same problem again in 5 to 10 years from now and be like, here we go again?
Yeah, probably.
So
probably.
Why do you think there's any correlation between, because software is this malleable thing that it's, when we build cities and houses, there's an importance. We can build new track homes, and there's a market for that, but there's also a market for like buying older places and maintaining them, taking care of them, updating. And that takes a lot of time and energy, and that's appreciated. But do you feel like I sometimes wonder if we think that we're too separate from like other types of construction because it's software. So it's just delete all these files and we'll just start over, and like, it's easy, it's free, but not. Do you feel like something wrong with our industry, how we think about this?
Yeah. Well, first is that's a very specific group of people, and like it is a voice that people are used to hearing, the idea of just rewrite it because it's all garbage. But there are lots of people that feel very differently about it. I was giggling because as you were saying this, I was imagining in my head the programmer's equivalent of This Old House. Like, what if we took like a legacy system and we just did a series about like very carefully restoring it to its original condition? Unfortunately, I don't know that we see code as like a craft in that sense, but there are definitely people like myself who are really fascinated and think that legacy systems are quite lovely. And one of my favorite conferences, which was put on once and has not repeated itself, which makes me very sad, was this conference called Systems We Love. And the premise of it was like Papers We Love. They were going to invite a bunch of speakers to just talk in depth about one system that they either had worked on or had learned about, and like everything that they loved about it. And so it was like a bunch of deep dives into architecture and stuff like that. And we were laughing about it during the conference because they had not planned it this way, but every single speaker had picked a legacy system. So we ended up referring to this conference as like Antiques Roadshow Computer Science Edition. But it just goes to show you that like there are a large number of people for whom legacy modernization is not automatically about a rewrite because they genuinely enjoy and appreciate old systems. I think I just look at like all of the times that like Lisp has come back into fashion in one way or another. And I feel like there are certain elements of technology that they're paradigms that have a historical relevance. They have a kind of a provenance that people do, you know, kind of come back to many times within their careers and like refined appreciation for. And so I'm not totally without hope, but I actually do think it'd be really fun to kind of do like a This Old House for like computer systems.
I think that would be very illuminating in that, like, hearing how people approach it. I think one of the challenges that I think we have in our industry is because a lot of writing about projects and software projects or blog posts, books, what have you, either you can't always, I don't feel like they can always be very, very specific about what the company that they're currently working for, what their software does, because there's proprietary information and business logic. So it's not like you get to see, how did we refactor this? You have to kind of talk about it in maybe a slightly abstract way, or maybe do a talk about it, and you can show snippets of code, but it's not necessarily like, rarely get to, unless you're like a consultant that comes in and get to go look at someone else's code, you don't obviously get to see what's going on behind the doors. You just get to hear these stories that make it out. And so you have to be kind of slightly abstract and big picture about it, I suppose, not be like, here's this crazy model thing that we had, and we needed to refactor this stuff over, or we split this over. And so sometimes I think it's difficult for some people maybe in their career to know what that even really looks like until they do it themselves or have an opportunity to witness it within their own teams. And not all teams that have that are always in that space to be able to do that, because they're just like bug fixing, providing maintenance, doing whatever on the software project to take those bigger step backs, or that work gets identified for the people that have been around longer, or the tech leads on projects might want to do that. And so people don't always get that firsthand view of it. Have you experienced anything like that? Or what do you think we as a community could be doing better to help share these stories, to help people appreciate the upkeep and restoration aspects of software development?
Yeah, for every system that I talk about in depth, there is always at least 3 people that are very anxious about me doing that and would prefer that I not do it at all. And so there are various strategies I have of approaching that. The first one is just kind of not mentioning where that system is or any information that would identify where that system is, right? Like, and in a lot of ways, it's easier to do that than people assume. Like, if you're talking about a database and like how it interacts with a fleet of web apps, it isn't necessarily relevant, like what the data looks like or where the data comes from or like what the web apps are doing all the time. But the other way is to sort of like abstract the system a little bit, like loosen some of the details. I think one of the ways to solve this problem is to kind of encourage more of like small mentor groups where, I mean, the reason why it is a problem to speak about legacy, so well, any kind of system and architecture is because generally speaking, the way that we share information is on a stage at a conference, right? But that doesn't have to be the way that we share information, right? Like, and inside within organizations, it's not uncommon for people to do architectural deep dives where they kind of go into the history of like why decisions were made about systems. What I think would be interesting is to get more of a practice around doing that across organizations on peer levels in a way that's confidential and safe. Because I think meeting with a handful of engineers and discussing problems and challenges and quirks of systems, I think there's a fairly hard tolerance for that sort of professional knowledge sharing. It's just about scale, really. When you start to do it and it's posted to YouTube, people start to get very nervous about intellectual property. So that's sort of my take on it.
I think one of the things that we often have to do is maybe lean on some open source projects so we can show how we might do things. But oftentimes open source projects are nothing like behind the scenes projects, or some proprietary software within an organization, especially if you're like interacting with some libraries or some open source web app thing. And it's like, well, kind of this is so very much generalized. Most of those projects tend to be kind of multi-purpose in some ways. It's like, this is only going to be applicable. This piece of open source project web app is only going to really ever need to be used by a company that prints labels for a business. It's like, they're probably not going to build that and then necessarily open source the whole thing so that their competitor can operate their business in the same exact way. You have to kind of pick, like, where can you show code examples of how you would reapproach things with like real business problems, not necessarily generic version of those types of problems that you would see maybe in an open source project because it's like a blog or something. Like, that's maybe not the best way to kind of illustrate that. Sometimes it's not bad. It's just, but I think it's hard for people like, how do I reapply this? It's a very similar way. I read a lot of business books as someone that runs a business, and most of those business, like, I think a lot of the businesses that would benefit the most from these books on how to organize your business or how to market your business rely on like product-based business or something. I'm like, what if you're a company that's like an agency where, or even a software team development related books, like, this sounds great if we just only worked on our own software, but when we work on a bunch of different companies' software, it's really hard to apply directly the lessons we're taking from people that work in product related companies.
Yeah. And you also have to appreciate that we're kind of right now going through a very natural kill your darlings phase where a lot of people are looking at like the writing that was done before on best practices of software engineering, like, for example, design patterns, and just looking at it and going, wait a minute, there's no actual evidence that this is a smart thing to do. Where did this actually come from? What was the experience that these learnings came from? Or did this person just make this stuff up? And often the answer is yes, this person made this stuff up and it was used for a while, but like maybe not the dogma that people expected it to be. And so it's kind of interesting. It's an interesting time for software engineers because we're kind of reinventing what the normal patterns of behavior are. And there were a lot of people that spent years just optimizing for a particular style of like perspective on software engineering. Like, I'm very, very much against the 10x software engineer idea. And I push back on that really hard with the teams that I run. And there are lots of engineers that like have basically grown up with the idea that that was your career goal, to get to the part where you were like a one-man engineering team and you could just do it all. And like now the industry is changing its attitudes towards that. And like a lot of these people, it's like, well, wait a minute, hold on a second. Like, who am I in this like different model, in this different paradigm? So
it's fascinating seeing how things evolve and return and like things get revisited. But yeah, I hear you on the myth of the 10x developer there. I want to pivot a little bit and talk about your book, Kill It With Fire.
I mean, we've been talking about the book the entire time. We just didn't.
So for the listeners that aren't familiar with it yet, who is your target audience for it? Is it just any type of software developer, or are there certain types of people listening? If they're listening, assuming that at least more than just you and I hearing this conversation, for those listening, like, what sort of scenarios do you think this would be most helpful for them to like go pick up your book and dive into?
Yeah, so it is written for roughly two groups of people. The first are software engineers, and I don't really have a specific software engineer in mind, although I will say that the vast majority of my experience is in web-based systems and either taking old systems and answering that question of, are we transitioning to this web-based system, or dealing with like the development and maintenance of web-based systems. So there is a bias in like the types of examples I think about and like the types of experiences that I had towards that, away from like low-level computing, embedded systems, and other types of software engineering. but it shouldn't be so much of a bias that it's completely without value. And the feedback that I've gotten from people from different types of software engineering that have read it has been that they've still found it to be valuable and interesting. The second group of people that I really wanted to target were really more of the people on the business side. So like CTOs, CIOs, CISOs, people who are in charge of leading these efforts, who generally kick off the modernization efforts, and trying to really give them a very clear picture of like, one, why do these things go wrong? Why are the talking points that you gravitate towards maybe not the right solution to your problem? So it is very common for a senior executive to hear a bunch of noise about XYZ technology or tooling and to just decide that this will obviously fix all of the organization's problems, and then to come in and top down and say like, we're going to cloud, guys. That's the thing. I've heard all this stuff about how the cloud is where everything is, so we're going to cloud. Sometimes that's the right decision. It's not necessarily the right decision because it's a buzzword of the moment, right? And so cloud is a good example, but AI is also a good example. I have this long conversation with people these days about like, well, what is AI exactly? Because it's not, in my opinion, a distinct set of technologies. It's really, I would argue, it's a user experience. When we design the computer program to run as if to give the suggestion that it has agency and it is making decisions, we call that AI. When we take exactly the same technology and we put it in a different context and we don't present it as if the computer is making a decision, we typically just call those things algorithms and statistical models and leave them as that at that. So there are like lots of little patterns of behavior that the higher level of the organization gets locked into that kind of make it very difficult for the engineering level of the organization to be successful. So I also wanted it to be accessible to those people with the hope that maybe we could reach a few of them and like make life easier for engineering teams or like consultants being brought in to tell them like how to do all the things they want to do.
That's interesting. Just so that we have maybe for myself and the listeners, what do you mean by modernization?
So I use the word modernization because it's the common language, but one of the first things that I tell people about this is that for me, it's not about modernization because modernization implies new system good, old system bad, and I don't believe that's true. My preferred way of thinking about what we're doing with legacy systems is restoring them to operational excellence. So, I mean, the less flashy way of saying that is, can you run and maintain the thing, right? If you can run it and you have defined SLAs, and you are within those SLAs, whatever they may be, and you have a monitoring system so that you can know that you're within those SLAs, and you can make changes to it, then I mean, keep on chugging with that COBOL mainframe. Like that seems fine to me, right? It's I think the problem becomes when people can't maintain them and they can't operate them and what level of performance they have is whatever the machine feels like giving them at the time, and they have absolutely no way of knowing about what it is. Like that's the part where I feel like, no, full stop. We need to make serious changes now.
We'll be back with our interview with Marianne in just a moment. Hi, it's me, Robby. I just wanted to take a quick moment to say thank you for making time to listen to the Maintainable Software Podcast. If you're finding these conversations valuable, please consider sharing a link amongst your peers and or writing a review on Apple Podcasts to help spread the word. Also, do you know someone in the industry that we should be speaking with on Maintainable? Shoot me an email to robby@maintainable.fm and state your case. And now, let's get back to our interview with Marianne Bellotti. What about in, just knowing that this is an area that you've spent a lot of your career in web development in particular? Let's say that you've got say there's a monolith application written in Ruby on Rails. That's primarily where I work in that space, and which wild to think that I've been doing this for like 17 or 18 years now with that. I'm like, that sounds wild. But I think one of the things that I've often heard people struggle with is like knowing when they should split things apart into microservices, because that's been a thing. And I feel like that's maybe even started to the pendulum is swinging back probably the other way in some ways at the moment now. But also there's a lot of JavaScript frameworks that have come out over the years. And so back to the 2007, the JavaScript tooling that you might have used with a web application then may not be the thing that most people today are familiar with or feel like is still supported, or they're not getting new patches or what have you, or seemingly has been abandoned by the wider community. So there's this impulse by developers to be like, well, I know that the core of the application is still running on older stuff, but maybe we can start replacing the old JavaScript frameworks with newer ones. And the question is like, well, when is that going to be old again? Or when is the new one going to be old? And then what's next in 5 years?
Yeah, the front end stuff is crazy. I mean, like, I tend to stay on the back end side, so I have a little bit of a privilege here. But like, I am blown away with how quickly the front end stuff changes. And it's not clear to me that the changes are actually beneficial all the time. Like, I will admit to being now a bit of a Luddite in that I'm not exactly sure why a JavaScript framework needs a model view controller format, but I'm sure that there are many people on Hacker News right now writing furious like commentary on exactly why that is necessary and critical. So I have great sympathy for front end engineers who are kind of looking at like, when do we update the front end? Because it goes so fast that I can't even imagine how to keep those decisions on the rails, right? Like, it just seems like there are so many places where. And in fact, I've been at organizations where they finished refreshing the entire front end design system and they get it done and they ship it to production and then they start the rewrite on the next version of the front end design system. So I don't know about that, but I feel like in general, one of the things that I've learned is that the same skills and perspectives that make dealing with legacy systems and figuring out how to restore operational excellence easier also make building new systems from scratch easier. A lot of the times that's the thing that I say to software engineers is that, like, I didn't want this book to be seen as like only really relevant if you happen to be dealing with an old computer system. I wanted people to understand that, you know, these sort of practices will also really help you on your new systems or the things that you think aren't that old. Like, if you are dealing with a web-based system from like 2015, that's actually pretty old these days, right? And so there are going to be some things that are going to resonate really, really hard for you in like what I've written in this book. So sometimes people ask me, like, why did you call it Kill It With Fire and put a dumpster fire on the cover of it when you really love legacy systems all that much? And I'm like, because if I had called it a love letter to legacy systems, no one would buy it, right? It's like people buy it because they're expecting me to tell them horrific stories. And there are some fun, horrific stories in the book, but like, it's kind of a little bit of a bait and switch there around like, hey, this is accessible to people who don't see their role as legacy modernization.
That's good. Definitely include links to that in the show notes for everybody as well. I've only been able to read a couple of the sampler chapters, so I'm going to definitely pick that up. I'm really curious to learn more about your bait and switch there. But as someone that employs software developers, I've had employees that are very nervous about focusing on maybe a technology for too long because of their resume and what access they might have to new things in the future to work at some other company. And so they feel like, well, you only focus on these few technical stacks. That's going to limit me in the future if I don't have exposure to all these different things. And this is the thing that everybody new is using because that's what everybody that's writing blog posts or articles or giving keynote speak at large conferences or talking about these new things. So we all need to, if we're not going to rewrite this in the new technology, then I'm going to have to go find a job where I can get exposed to that thing because I don't want to fall behind, and I think that's an interesting, I'm going to assume that there's some listeners out there that probably resonates where they're worried. And so I think sometimes organizations will end up making decisions for retention purposes. Like, fine, let's let them do the rewrite. We don't want to lose these people. They seem excited about it right now. Will they be excited 3 years later after they finish, if they finish it? That it becomes like this interesting struggle of like, are technical decisions something the team is always putting the best interest of the organization above their own. I'm not trying to make it sound like they're being selfish, but there's, a little bit of selfishness. Someone had to decide the original technology they use in the first place as well. And what went into that decision?
And I think this is the value of just immediately removing the argument, newer is better than old, from the table, right? And forcing the conversation to be about the benefits that we get from doing this versus the risks and the costs, the reasonable costs of doing it, right? Because often those kind of resume building exercises, and that's the way I refer to them, as resume building exercises, they are hidden under the, well, it's new, right? It's new and it's better and it scales better and it's more performant. And like none of those statements are ever qualified with actual like data, right? Like you're going to tell me something scales better, then the first question I'm going to ask you is under what use cases and like what metrics are we using here? Are we talking about performance? Are we talking about latency? Are we talking about availability? Are we talking about something else? Like what are we really looking at and judging it by? And what are our real priorities? Like if our current technology meets our SLO, like do we really get that much more benefit from it just being a tiny bit better? And so actually forcing people to have these conversations kind of helps you like weed out a lot of those things where it's really more about like, I find it less about people worried about they can't get a job and more about, oh, I heard about this new technology. It sounds really cool. I really want to play with it, right? Which I get, like I like playing with technology too. We all do. That's why we are in this field, right? But, having people make these kind of critical business decisions based on their desire to sort of play around with something, it's not good for anybody. And it often results in technology that is now in production, that no one knows how to get out of production, that no one really is able to maintain, and that may be actually quite difficult to run based on like its current configuration. So yeah, I would say that when I have career conversations with engineers where we're talking about their future, as a hiring manager, the space is so competitive for quality engineers that very rarely do I get the privilege of saying, I need a person with this very specific form of technology, and I only want to see resumes and I only want to interview people with this very specific form of technology. What'll frequently happen is that I will say to my recruiters and the team that I'm working with when I'm trying to fill a position, I need somebody who has this set of skills. And it can look like this, or it can look like this, or it can look like this. And so a lot of times, like just keeping front end for the example, we won't say we need somebody who has React. We'll say like we're using React on the front end. If they have that, that's great. If they have any of these other JavaScript frameworks, they're all just JavaScript frameworks. They will learn React. It's not a problem. It's no big deal, right? And so we do this with languages. We do this with certain types of technology. And that's the way real hiring managers tend to hire, because if you are too nitpicky and specific, it is going to be an even worse experience trying to find the right person.
I think that's a good thing for people myself to hear, because we do specialize in specific technology. And so there's an interesting thing when, as a consultancy, I've tried to move beyond like, well, I want you don't have to love Ruby to be, necessarily, but if you haven't already drank some of the Kool-Aid, are you going to be excited about like the benefits of what I perceive why Ruby on Rails is this great platform to work with for web applications, and we can have a lucrative business out of helping companies improve their applications and deal with some of the stuff that's been lingering in their applications for a long time, or help them with their recruitment challenges and stuff there as well. But it's this interesting thing where like, well, could we just bring in someone that was a really good .NET developer and they'll pick it up in the next few months, and then in a year from now, I'd be probably surprised that I even thought twice about that, I suppose. So
yeah. The team that I'm currently working with, we are Go and gRPC with protobufs. And so the pool of people in the software world that are comfortable writing code in Go is small. The pool of people who know what gRPC actually is and how protobufs work is even smaller. And so I spend a lot of time talking to candidates and they go, I don't know these technologies. I was like, neither did I when I started. I learned here, I will give you all the resources that everyone on my team has used to get up to speed with them, and then you will be fine, right?
That's a good point. So thank you for that. I needed to hear that today, I think, as we start reflecting on our hiring plans going forward in next year. So a couple of quick last questions I wanted to dive into with you. I know that you've been working on your own programming language. I have a project for that. Could you tell us a little bit about that?
So I have gone very, very deep down the rabbit hole of formal verification. And so I'll give you the quickest answer I can give to the question, what is formal verification, in order to give proper background. When we write certain types of code, we need to be able to mathematically prove that when we get an input, we get a particular output and that they behave correctly. And so the way we do that is with Boolean logic. It's called first order logic, which is essentially we set a series of true-false statements, and then we have the computer tell us whether there's ever a scenario or a state that is possible that we think is impossible. So if you have any experience with a language like Prolog, it's a very similar concept to logic programming. I love it, right? Like, because I am a person that likes a good dumpster fire, as we've already established, right? So as soon as I started digging into the world of all the strange, wonderful things that can go wrong with computer systems, and I started to learn about a little bit more of these practices, I was like, head first, this is cool. The problem with formal verification, and I spent a lot of time like talking publicly about these kind of challenges, is that it doesn't really fit the web development software lifecycle for a couple of different reasons. The first is the turnaround time that we are expecting from software engineers. When your classic web development engineering team takes great pride in shipping updates to production multiple times a day. And the idea behind formal verification is you write a specification for the system with your requirements, you mathematically prove all your requirements, and then you write the code as close to the spec as you can. And those two things are like at ends with one another, because with all of these updates, you are very quickly drifting away from the specification. And like, when do you update the spec and all of that? But the other reason why it doesn't really work is that distributed systems, these kind of systems that we build for the web these days, aren't really about algorithms and mathematical correctness so much anymore. Like, we definitely have algorithms, but we don't generally write them. We usually have a library for that some very much smarter MIT person has written the algorithm in like our desired language, what have you. Really what most software engineers in that space are doing are creating feedback loops, right? Where the state of the system is changing as a result of other changes made to the system and how resources are being distributed around the system. And like, that is a completely different type of challenge. And so what I found really interesting is that we actually had like mathematicians from MIT develop a way of modeling systems that looked like that. But they did it for the business school in MIT, not for the computer science school in MIT. So it's like grown, it's called system dynamics. It has grown up in parallel to a lot of the formal verification work, but completely disconnected from it. And so about, I guess now 2 years ago, I was going into lockdown like everybody else. And I was kind of thinking about like, well, why couldn't we build a model checker for a system that's structured under a system dynamics perspective? Like, there didn't seem to me to be any particular reason why we couldn't use the tooling for formal verification to run a bounded model and perform certain tests on it. And then I just sort of became obsessed with that idea because, like everybody else during lockdown, I had nothing else to do with my time. And I'd always wanted to write a compiler, right? That was one of my kind of like milestone goals. I feel like I will learn a lot and it will make me a better programmer. And I'd always wanted to do it. And so a work colleague of mine one day said, well, why don't you just do it? And I'm like, why don't I just do it? So the language is called Fault. It is in like a rough, awful pre-alpha state, which is my most favorite time of the project. And it is really about like trying to crack the way we represent systems and then reason about them. And I've been spending a bit of time these days talking to potential sponsors and funders about this idea of like, not just about the verification part of it, but more about the reasoning part of it. The fact that, for example, when you want to write a policy regulating a form of technology like AI, it's very important that the people who are handling the kind of policy, legal impact side have the same idea about what the system is and how it behaves as the people who are building the system. And that is super, super difficult. So I'm, in addition to being interested in how we just model system behavior and like what we can learn about our ideas about what systems are doing from modeling them, I'm also really interested in whether we can use these kind of things to transfer information from one group to another, regardless of their level of technical ability. Like there is definitely a crew of people that believe that the only way we'll be able to like have good regulation of technology is if all of the policy people become software engineers on the side. And I'm like, that just seems unrealistic, right? This is a life's pursuit, right? And you can't balance both of the needs of that. And so I feel like there's a communication issue here that I find very, very interesting, and how we think about what systems are doing and what behaviors should be impossible on them.
That's interesting. Yeah, it is interesting. I don't know how much of that went over my head because as a
it's kind of a lot, actually.
as a layman web developer.
Well, I'll give you an example, and that might help a bit. We talk about impossible states, right? So when you're modeling a system, you're essentially creating a state machine. And when you're doing model checking on it, you're telling the model checker, I think it is impossible for this state to ever happen. Or sometimes I think it's impossible for you to transition from this state to this state. When you're dealing with, like, say, an OS, you're dealing with kind of these algorithms and these processes that are very straightforward. They're deterministic, essentially. So it's very easy to do that. One of the states that we might see as unpleasant in web development is if we have a scenario where a load balancer is spinning up a server and killing it, and spinning up a server and killing it, and spinning. So your whole system is basically grounding to a halt because for some reason, like you're not scaling up correctly. Like that's the thing that people have experienced. And most people would say, like, I would like to create a system where that is impossible. However, the fundamental activity of what's going on, the load balancer spinning up a server, shouldn't be impossible. The fundamental activity of the load balancer killing a server shouldn't be impossible. And so like what's actually unfortunate about that scenario isn't the act of either spinning up the server or killing the server. It is that feedback loop, is that whole loop of how all of those activities kind of chain together. And that's very difficult in a normal method of formal verification to model. But when you think about it in terms of the way systems dynamics thinks about it, in terms of pools of resources and then flows that basically either increase or decrease those pools of resources, then it becomes a lot more accessible to model. It's a lot clearer what that model should be. And what I'm trying to assess is like, okay, and now when we essentially take all that and we translate it into a list of rules, do we get anything useful out of that? And I don't know the answer to that because I haven't finished writing the compiler, but stay tuned.
Great.
Probably 2-3 years from now, I'll come back and I'll be like, yes, we know interesting things, or no, that was a terrible idea.
Sounds great. I would love that. I will. Is there something we can find? Is this like we have a website for this or something people can find online?
It's on GitHub, so you can just go to my GitHub profile, which is Bellotti, or you can search for fault lang. Fault is in fault lines, and it will pop up. And then you can give me a code review telling me how like sloppy my code is. It's well deserved. It's fun when you're writing code to do something that you've never figured out before. It's really interesting, the kind of stuff that comes out when you're just banging your head against the wall. And one of the things I had to learn in this project was the intermediate representation that LLVM uses, and it was like Greek to me. It was baffling to me. And so now I'm at the point where I think I mainly understand a lot of like the broad strokes of it, but like I go back and I look at that part of the compiler and I'm like, yep, this was like 8th hour revision trying to get the thing to work kind of moment.
That's great. Yeah, I'll definitely go check that out myself as well and include links to that in the show notes. Is there a non-software, non-technical book that you find yourself recommending to peers on a regular basis?
Oh God, like, yeah, I'm a huge safety geek. So like literally everything Sidney Dekker has written, I will recommend to people at various points in time. I think the one that I tend to recommend to people, unless they have a very specific interest in that they're looking at approaching. The one that I recommend first for people is called Drift into Failure. And like, I love everything. Again, this is the social scientist in me coming out. I love everything in the ergonomics space and just the kind of intentional design space as well. So, but those are the things that I recommend to people a lot, is like looking at what has actually been done in the field of safety science, because even though they're not technical books, as a software engineer, I think people are quite surprised to find that a lot of the challenges that we have with systems have been documented and studied since like the 70s and 80s. And there's actually a lot of lessons learned that we can pull from like what they've been doing in manufacturing safety and in industrial safety and apply right now today in how we do things. And have pulled most of what people identify as a postmortem procedure and an on-call procedure comes directly from safety science.
Oh, interesting. Oh, okay, cool. I'm going to, you said that was Sydney Decker?
Yeah.
Cool. I will look that up and include links to that for all of our listeners in the show notes as well. So where can listeners best follow your thoughts and ruminations on software engineering online?
I mean, it's still Twitter. I don't know. Like, hopefully that will be still true by the time this episode comes out. Who knows with Twitter these days? Yeah, I mean, like, generally, like, Twitter is like my LinkedIn. I'm not a huge fan of LinkedIn as a platform, so I tend to just do all of my professional networking on Twitter. Yeah, that's all I can think about. Like, I've aggressively minimized my social media preference.
And you've got some books and stuff as well, and so we'll definitely include links to all of those for everybody in the show notes. And with that, it's been such a delight having you join us on Maintainable, Marianne. Thank you so much for talking shop.
Yeah, thanks for having me. It was great fun.